this thing on. We're good now?
Yep.
All right, here we go. So the two things we're talking about, ASA and AAS. What do you think the ASA stands for?
Angle side.
Angle side. Angle, AAS. Angle,
Wait,
angle
can it be
side.
angle? Because we have side and side.
That's a great question. We'll find out. No one ruins for us to recognize them. But it could be. So let's see. Let's take our first notes for this. Before we start getting going on, our first little thing we haven't talked about is this included side. Just like yesterday with the included angle when we had SAS, it was the angle that was between two sides. So what do you think the included side is going to be? In between two angles. Very good. So let's look up here. So it's the side formed by two angles of a triangle. So for angle R and angle T, what is the included side? Well, let's outline it. Angle R is right here. Angle T is right here. What side is in between those two angles? What is it? RT is correct. So this is RT right there. RT is the included side. It is the side in between there. That is your side. RT. Real easy. It's just in between two. That's it. So now we can start talking about our shortcuts. So the first one is the ASA. You guys already knew what it was. It was angle, side, angle. Definition: if two angles and the included side. The included side of one triangle. Figures again. There we go. Of one triangle are congruent with two angles, the included side of another triangle, then the triangles are congruent. That's what the shortcuts tell us. We're trying to figure out the least possible way, the least number of points or pieces that I need to say triangles congruent. So I need to have that two angles that include a side. If I do, then they are congruent. Brings us to the next one. Angle, angle, side. If I have this. If two angles and the non-included side, so a side that is not in between there, non-included, side of one triangle are congruent to the corresponding two angles in the side of the second triangle, then they are also congruent. Now, Kanaji brought up a great point a little bit ago. We're talking about the four ways that we use: side, 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 angle, side, angle, and angle, angle, side. Is there another combination that possibly you could use using those two letters? Kanaji, what'd you say? Angle, angle, angle. I would agree. But in this case, you cannot call triple A. Triple A is not one that we can use. A. And you're saying, why can't I call triple A? Why can I not use triple A? Well, I'll show you right here. So this little box right here, draw this little example, follow along here. So I'm just going to show you with this. I'm going to draw a triangle. This is an equilateral triangle.
You didn't draw it.
I just drew that. Well, how did you not? How to get there?
You did that?
Yeah, I drew it. Thank you. I did. So I did that. There it is. It's an equilateral triangle. So if it's equilateral triangle, what do you know about this triangle?
Equal side, equal.
Equal size, equal angle. So what is each angle in this triangle? 60. I agree. So this guy's 60. This guy's 60 degrees. 60. 60. All right. So we agree that's an equilateral triangle. All the sides are the same. All the angles the same. Correct? Good. I'm going to clone this. Clone means I'm going to make an exact copy. So make an exact copy of this guy. Cloned it. And then I'm going to make it bigger. Is that still an equilateral triangle? It better be. I just copied the same exact one. I didn't change anything else. I just made it bigger. So what are the angle measures of this one still? It's still an equilateral triangle, right? So 60, 60, 60. Let me ask you, are these triangles congruent? They're not the same size, are they? No, they're the same shape. They're both equilateral triangles, but they're not the same size. Because of how angle, angle, angle works, I can change the dimension of the triangle. We will use this when we start talking about similar triangles. But as far as congruent triangles, AAA does not work. You cannot call them. So that's why I keep saying AAA. You can't call them. The Automobile Association of America, AAA, can't call them here. Does not work. Is there another combination of those two letters that you could use that we have not used yet? Another combination of those letters? Gary? All right, flip that around. Think about it. Don't say it out loud. Flip it around. Side angle. Right? Is that what he said? Ah, he said that. So we cannot use that one either because I can't write it out. But it's going to be at money sign. Get the letters down. You guys put the letters together. Okay, I'll write it down. You guys want A S. I can't do it. I can't put this on the board at a school like this. But it's going to be at sign, money sign. All right? Angle, side. Will not work. Okay, you can't use angle, side.
Side, angle.
You can't flip it around either. It's not going to work. Any of these you flip around, not going to work. All right? So I can't use that one. The reason why I can't use this is because that angle has to be between those two sides. If it's not in between there, it's going to affect it. That other side could be affected by it. It will not work. We'll show you later why it doesn't work if you really care. But just remember, you can't call AAA, and that word is not school appropriate, so you can't use it. It's not because it's not school appropriate. It's just it won't work. So those are the two that do not work. That can never ever be a reason. All right. So now you have 4 of those reasons in your toolbox. Let's go ahead and try to solve using those 4 reasons. So we're going to use any of those postulates. Side, angle, side, angle, and angle, side. Again, remember, what we like to do is just look at one of the triangles and see if it's identical in the other triangle. Starting the furthest most piece, I'm going to look at this triangle NTY. This guy right here on the left side. I'm going to look at that one. And I'm going to figure out what pieces I have. First off, how many pieces do you need minimum for a shortcut? 3 is correct. This left triangle, do I have 3 things marked in there? I do. Got that. Now let's see the order they're in. Start at the furthest most piece. So it looks like I got this angle right here. Angle with 2 arcs. Got to loop around. Can't go this way. There's no side. So I can go the other way. So angle, what is this? Side, angle. Okay. So that's good. 3 pieces, angle, side, angle. Angle, side, angle is appropriate. I can use that one. Go to the other triangle. So I went from 2 arcs to 1 tick mark to 1 arc. Do the same thing. Here's my 2 arcs. Coming around to 1 tick mark. Is that 1 arc right there, though? It is not. Since it's not in that location, yes, I look up there. I realize they do have the same measurements, but they're not in the same exact order. Order matters. Because it's not, this is going to be a none. None of the postulates work for that one right there. Not going to work. Not in the same order. Order matters. This would be an angle, side situation. And this one's angle, side. Not the same spot. Can't do it. All right, B. Number B. Going right there. All right. Oh, well, you guys just told me you need 3 pieces for a shortcut, right? That's what you said? Well, if I look at one triangle, just cover up one of them, I've only got this and this. So there's only 2 pieces. So this has got to be a none then. None, right? None. Only 2 pieces? Why you shake your head? There's only 2 there. 3 right there.
You're right.
What do you say? They are both connected right there in the middle. What type of triangles are these?
Bow tie.
Bow ties. What do bow ties always have from the end of time? Vertical angles. So there really is, even though it's not drawn, you know these angles right there are congruent. Now I have those 3 pieces that I was looking for. Now, what 3 pieces are they? Cover it up, one of them up, I don't care which one. Let's work our way around. So I'm going to go up here. I'm looking for one on the right first. Start at the very top, or the furthest most piece that I'm given. I've got an angle, looping down to an angle, going down to a side. So angle, side. Now let's see if it's the same in the other one. So I went from 1 arc to 2 arc to 2 tick marks. All right. 1 arc to 2 arc to 2 tick marks. Yes, this one works. This is an angle, side situation. AAS. All right. Number C there. Well, those were vertical angles. What type of pair are these in C? What type of triangles are those? Talked about them yesterday. You're right. You're saying the property is reflexive. I agree. We call these shared sides. And you're exactly right saying they're reflexive, excuse me. And the side they're reflecting is right there in the middle. So what? Yeah. Right there. That's the side they're sharing. So what postulate, excuse me, tells me these are the same? Side, 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 right? So she's saying, oh, I got a 4 right here, 1 tick mark, 3 tick marks. 4, 1, yeah, side, side, side works. Does anyone have something different? Yes. ASA? Angle, side, angle? No way. I'll check it out. All right. 1 arc, 1 side, 3. So angle, side, angle. Okay. Yeah. Oh. Yeah. Angle, side, angle works. Someone have something different? Gary, you have something different?
SAS.
You're saying side, angle, side? Well, we'll find out. Go from the side of 4 to 1 arc to 1 side. 4. Yeah, that works. Stats. Anyone else? What else? What else you can have here? Probably one more. Perhaps one we've learned today. Maybe. Yes? AAS. Angle, angle, side. Angle, angle, side. Angle, angle, side works. So this is a case where all of them work. Now, why is that? It's because this is a CPCTC situation. Because all of my sides are marked and all my angles are already marked. So if all of them are marked, then you know all the shortcuts work. All right? So CPCTC, it works out. All right. D. What about D? Who's got D? Anyone? No one? What do you say? None? What do you mean? I got 3 things marked. I have 1, 2, 3 things marked, right? I don't have any sides. You can't call AAA. It's very, very tempting because you have 1, 2, 3 pieces, but they're not the 3 pieces I need. If I just had one little side marked in there, I could then say yes. I could say angle, angle, side, or angle, side, angle. Lots of options there. But based on what I have, and I agree, they look like they're congruent. They do. They look very similar. But since there's nothing marked, I'm going to have to go with a big fat none on this one too. None as well. How do you feel about that? All right? Well, let's do our proof of this. Now, some people are saying, I still struggle with these. First off, if you're saying that, you're probably one of the people that aren't trying these board bringers that we're doing. Second one is, it will get better today. Because now you have 4 shortcuts, and you're going to see that pattern. We have a work day tomorrow. We'll do more stuff with that as well. But once you see the pattern, I'm telling you right now, without doing any work, I'm telling you, I could figure out 9 bits of information without doing any work, just by looking at it. You get 9 points just by looking at this and understanding how it works out. And then another one will fall in place once you do it. But let's go through. Every one of you knows there's 3. There's 3 for sure you got. Write those 3 down that you have right now. Get the 3 that you know are going to be there. Get those points. Don't wait for me. You try it on your own. I'll go faster than I will. Your handwriting's much nicer. What 3 are you going to have always? There's 3 points. If you leave this blank, we're going to have a talk down the hallway. So you can't leave these blank. You know the 3. Yeah. Would you rather have 3 points or 0 points on your test? Could be the difference from an A and a B. Could be the difference between a D and an F. So let's. Which one does one go to? Oh, yes, great question. The P over there is a formatting error. It's right here. It's saying parallel. It dropped over. So change that to a parallel symbol there, guys. That's what it is. Just parallel. We'll try to catch those. So WR is parallel to ED. Write those down. All right, I'm going to start writing some of these. What was the number 1 statement you had? Statement, though. What statement was it? What was I given? Justice? The midpoint, yeah. So point L, let's read the whole thing, but yeah. Point L is the midpoint of we, I think. What else? Anything else was I given? To be clear, there's an and after. Matt, thanks for saying what?
WR parallel.
I like it. W, oh, R, not we again. Come on, we. WR, wide receiver, is not congruent. What's going on? Congruent. What am I thinking? Parallel to Ed. And we already said that. I think it was Riley. Who I forget? Someone said it. Someone said given. There's 2 points. What's the third point everyone should get in here, even if you say, I don't know how to do this? The what you're trying to prove. And that's, we're showing that whirl is congruent to Edel. So triangle whirl, WRL, is congruent to, is what I'm trying to prove here, EDL. So right there, everyone should have this in this room. If you don't, you're just distracted by your phone, you're not doing something, because these are three points. They're going to be there. That's them right there. Now, let's start thinking about what type of triangle is this? What do I see in the given? What are some other things I know based off this? So first question, what do you think could be the next reason? We're not going to solve it yet, but give me one reason. There's a couple. Well, how'd you get that? If there's a word, it's going to be definition of that word. You said midpoint. I definitely agree. Def of midpoint. Look where we're at. We now have 4 points. Pretty straightforward. What else do I know about this triangle without doing any work? Perhaps its shape or something fancy. That's, oh, yes. What do bow ties always have? Vertical angles. Well, here we go. Step 3. Vert angles congruent. Look back at that given information. There's one more thing we could do without doing any of the work. And we learned it yesterday. You know, it's not as common as some of the other ones, but you will. Every time you see this will be a reason. And it has to do with this. Remember from yesterday I talked about this? Something with those interiors. Which one is it? Alternate interior angles. When you have parallel lines, you're going to have alternate interior angles. Alt. Oh, int. Int. Angles. Alternate interior. So look, we have not done anything. I have 1, 2, 3, 4, 5, 6. And I'm telling you why I said 9, because definition midpoint. You tell me what that means. It's in the middle. Tell me the points. Vertical angles. Tell me where the vertical angles are. Tell me these alternate interior angles. You're just naming them. Name those 3 things. You have 9 points without doing any of the work. But now we have nothing else we can do. Now we're going to do the work. So we said definition midpoint. Well, what does it mean to be definition midpoint? What's that really mean? Ooh, something along those lines, yes. We're going to figure it out. But midpoint means that it's in the middle, right? So I know that L is in the middle of we. Here's we. So what do I know about each of the pieces if that dot's in the middle? They're equal. They're congruent. Someone say, well, that's congruent to that. Now I just have to name it. So step 2, someone name you one of those segments. Name the one on the left down here. I don't care. WL. And order matters when WL, so EL is the other way you have to go. That's right there. Boom. 7 points. Well, vertical angles. Where are the vertical angles? RL, what did you say? Well, like RLT, I like the RL though. Stick back with that. But RL, the angles are right here. So RLW is one. Well, there's the other one. It's right across from it, right there. So I'm going to say angle RLW is congruent to what other one? Be careful. This flips. Because the triangles flip differently. See how this tick mark's over here and now it's up there? So we said RLW, what's the other side? DLE. DLE. Good. 8 points. Now, where are the alternate interior angles? And again, it gets easier with practice here, but I'll show you real quick. If these, if these are my parallel lines, one of these lines is transversal. We don't care which one you use, because it doesn't matter. We just change your final shortcut answer. But I'm going to say that one. Well, where are those alternate interior angles? Where are the angles that are touching that purple line and those yellow lines? Exactly right, Kaija. There's R right there. The other one's alternate interior is over here, D. So all I was saying is the alternate interior angles are angle R is congruent to angle D. You do not have to use 3 points for that one. Vertical angles, yes, every single time you have to use 3 points. These alternate interior angles, you don't have to all the time. You could if you wanted to, but since there's no other intersecting lines anywhere else, see how they stop right there? You can stop right there and it's called angle R.
I have a question.
Yes.
So we have to remember there's
RLD.
like,
Before we did the blue arch, you say?
yeah,
Okay, before we had the blue arch, we would not have enough information there yet.
because is RL and DL congruent too?
RL, and D, we don't know that. Okay, yeah, if that was the case, yes. If I knew that L was the midpoint of RD, that's what she's asking. I don't have that given up here, but if they said it was the midpoint of Lee and RD, you'd be done. It'd be a side angle side. But it wasn't given to us at that point. So that's why we go one step further. Good question. So that's congruent to that. Now, do I have 3 pieces in that triangle?
Yes.
What 3 pieces do I have?
Angle, angle, side.
Correct. Angle, angle, side. Guess what? Since I have those 3 pieces, I now know mine's going to be done. There's step 5. Here's step 5. Gary said angle, angle, side. Had your transversal been line we, your alternate interior angle would have been W and E, and that would have changed it to an angle side angle. Sometimes these are interchangeable with angle side angle. Not always, but sometimes they are. All right? Some of you are saying, all right, I feel a little bit better with it. Let's try one more.
In this proof, start filling out your bones just like we normally do. Statement. Reason. What's our first statement? What are you gonna write in as our first statement? Yeah, angle D is congruent to angle F. What else are we gonna write? Good. GE bisects angle D, F. And what's our first reason every single time? Okay, so far you know that much. And what are we going to write last? What's going to be our very last statement?
Always right
Last. Sam?
Give me a tell you like what it is.
Yeah.
Oh, angle DG is congruent to angle FG.
Good. Oh, so there's 6 for Sam. You know how there's a line above it? So then you just say Sam.
Oh,
But you're right. That chunk of
that's it.
information is going to go last. As long as you write it, you're good. What's different about that, though? What are we normally written? What are we normally trying to prove congruent? The triangles. This time around, though, we're trying to prove parts. That's what's a little different. But it's actually, we find it a lot more beneficial to you because it gives you more freebies. Okay? So sometimes you think, oh gosh, it's not triangles, it's parts, it's different. No. That's going to help you out so much more because whenever you're proving parts congruent, so if you're saying 2 segments or 2 angles, your reason every single time is C, P, C, T, C. Every single time whenever you're proving parts of triangles congruent.
4 3 points. 1. But wait.
There's another one because you're proving parts. Because in order to say that 2 parts of a triangle are congruent, you have to prove that those two triangles are congruent. So the statement right above that one is stating the two triangles in your figure are the same. So you just have to say that this triangle is congruent to the other triangle. And it doesn't matter how you name it. How do we want to name that purple triangle, the first triangle? DGE. Triangle DGE is congruent to triangle. If we went DGE, you have to follow that same exact pattern. How do we have to name that second triangle? Yeah, FGE. Because G and E are going to stay in the same spot because they're the same point. So we want to go FGE. Follow that same pattern. So right away, right off the bat, you have 1, 2, 3, 4, 5 freebies just by knowing that you're proving parts of the triangle. Okay? Questions over that part? Okay? Well, fill in all the rest of your shortcuts. What kind of triangles do we have? Special about these triangles, Gary? Now they are obtuse. Are they shaped? They're what? Yeah, we have that reflexive property because they're sharing in what? Well, they're sharing a side. They're sharing this side right here. So make sure you mark that in your diagram. And you know because they're sharing a side, it's automatically going to be the reflexive property. Yeah, very good. We know that's also going to be a reason because we have this vocab word, bisects. So we know one of our reasons is going to be definition of a bisector. So by just knowing those shortcuts, you have 1, 2, 3, 4, 5, 6, 7 points. And I'll tell you this is worth 10. That's 70%. That's a C. That's pretty good.
Versus some of you say, nope, not even try F.
Question, Gary? Like your notes? You should have your notes packet with you. So if we look here, whenever you have the reflexive property, all you're doing is you're just stating that the side they're sharing is congruent to itself. So for 2, we just say that GE is congruent to GE. So if you remember that, that gives you your 8th point. Whenever you have reflexive property, it's just that shared side congruent to itself. And then if you remember about the bisector, this line, GE, cutting this angle in half. Because it's bisecting it. Okay? Well, if it's cutting this angle in half, what do we know about this angle and that angle? They're the same. So you mark it in your diagram, and then write it in your proof. I'll name the first one. I'm going to say DEG.
Very important to mark your diagram. You won't be able to get the shortcut unless you do.
You won't be able to see it very well. You have to mark it. How do we have to name that second angle? We want DEG, FEG. Follow that same pattern. Okay? So there's your 9th point by just knowing those shortcuts. Well, do we have 3 pieces marked in our diagram? What 3 pieces do we have? We have an angle, then we have an angle, and then we have a side. Angle, angle, side. We have it. There is our, I'm not going to move it, 4. And our reason for that would be angle, angle, side. That's how we can state that these triangles are congruent. We have an angle, and side. Because we stated those triangles congruent, we know we're done. There you go. Nope.
No.
They're on the other side.
Yeah, we don't have that other, the side in between, is it? So again, by just knowing those shortcuts, all you really had to do was figure out what shortcut you used. So work on that. We'll give you a little reminder sheet tomorrow to fill out. So if you remember the shortcuts, you can use on your work set.
Get your practice out. If anything, do